So today, first of all, my name's Larry Sharp, and I'm going to be doing this presentation for you. Before I get started, I just wanted to say thank you to everybody that's joining. We see a large group of people that have registered for this particular presentation. Also want to say that we hope all of you are doing well out there. I know during these times, a lot of you are working from home. Just want to make sure that you're all doing well. Wish you all the very best. Hopes and prayers go out to everybody that will stay safe and healthy. So I'm going to get started with the presentation, but just to let you know, there are some additional people helping me that are going to be manning the chat room. So if you have questions during the presentation, feel free to go ahead and jump in and ask those questions. I'm going to keep everyone muted until the end of the presentation, then we'll open it up for questions as well. So we've covered this before, but we've done a few of these, a total of 4 or 5 of these presently, and we're going to be doing these on a weekly basis. We've got a lot of equipment that Chroma offers related to testing of power conversion type devices. Also, we include electrical safety and battery simulators. And then, of course, we incorporate it all into a complete automated test system that makes it a perfect tool for testing, both for research and development, manufacturing. We see these used in hardware in the loop. So we'll go into more detail as we go along. To talk about solar energy systems, this little block diagram is not all-inclusive, but basically you start with something which is a solar array panel or solar array itself. And the solar array, as you know, it gets its energy from the sun through the irradiation levels on to the solar panels. It develops a DC output current and develops voltage, and we'll go into how that works. That's the input to the PV inverter, the photovoltaic PV inverter, which will then convert power to AC and put it back on the grid. Not all PV inverters put power back directly to the grid. Some work as standalone, but today, for this particular presentation, we're going to be talking mostly about grid-tied PV inverter. We're also going to be noting some things about hybrid PV inverters. And hybrid PV inverters include something known as a charge controller for battery energy storage as well. And then, of course, we'll talk about a little bit about loading and the different things that are powered off of the inverter and how they interact with the unit and how they tie to the grid as well. So power generation, solar power, solar panels, arrays, power conversion, PV inverter, loads, just about any device that gets plugged into the grid, energy storage, battery, fuel cells, controlled by charge controllers now that are incorporated into the PV inverters, referred to as hybrid inverters. Utility power would be the grid itself, and then power distribution, metering, control, panels, etc. So Chroma's put together a number of different products to support this particular type of testing. They're used in a lot of different other applications as well that we're going to be covering in the future. But for this particular application, our 61800 regenerative grid simulators are perfect for simulating the grid. They're regenerative, meaning they can put power back onto the grid, and they're fully programmable, which makes them perfect for doing the various types of tests that we'll get into a little more detail. Our 62000H series of DC power supplies, all the way up to 15 kilowatts, parallel up to 1.5 megawatt. So we're not limited on size for you. We can go up to higher power, up to 1800 volts DC. And we can do the simulation of power with this one of solar array simulation. So we'll be happy to go into more detail on that in the other previous next slides that we're going to go into. We also have a regenerative battery pack test system, the 1700 family. And that will go into detail about how it actually simulates batteries as part of the energy storage system. And our digital power meters, how we use those to incorporate and also give you more accurate measurements. Once we get into the test itself, before we start, I'd like to just cover briefly, this cell just gives you kind of an overview of what a solar array electrical characteristics would normally be. So we know that the power is not regulated on the output of a solar array, and it gets gets a range of power depending on the irradiation level from the sun. And there's some various types of different solar cells, and each one of those will actually have a different efficiency or fill factor. And there's some very specific parameters related to these. Short circuit current, open circuit voltage, current at maximum power, voltage at maximum power, and maximum power itself. And when we look at these and plot that information, we're going to be able to go in and do the curve by plotting it, which gives you the voltage and current curve, the IV curve, and also the power curve, the EMP curve, as you see there, which is power and voltage. So we're going to start with talking about the solar panels, solar arrays themselves, some of the things that we can do to help you test them. Chroma has developed within their DC loads the ability to do what's called maximum power point tracking. And with this, we can actually sweep the load setting. And while we're doing that, we will measure voltage, current, and power and track the point of maximum power from a solar array. So this is done typically in a manufacturing test where the solar panel would be used with a artificial light in order to get a particular radiation consistent level on the panel. And then we would use our load to actually test the panel for its maximum power point under those conditions. The loads themselves come in two different versions. One is our modular 63600 family of product. They go all the way up to 400 watts and can be paralleled up to 2000 watts in a single mainframe. And then above that, we can go into higher voltages, higher power with our 63200A family of product, which is the one on the bottom. And with this unit, it still has the same maximum power point tracking feature built into it. And with that, you can do the same test just at a much higher power level. We also offer something called a solar simulation or solar application soft panel. In the solar application soft panel, we're able to actually run the IV curve and PV curve test and plot it and display it for you for your panel. We can also do a continuous measurement of maximum power over time and plot that information as well as collect and record all that data for you. It'll also be able to test for open circuit voltage for your panel. It'll also be able to test for short circuit current. And then it'll also be able to give maximum power, input power, current, maximum current at maximum power and your maximum power also. It looks like we may have a few people with their mutes, with their mics open. I'd appreciate if you would mute all your microphones so that we don't get interrupted during the presentation, and then we will unmute at the end. The next step we're going to go into is the PV inverter itself and some of the testing that we do for the PV inverter. We've offered you a test guide, and anybody that registered, please take advantage of this PV inverter power test guide. It's a great tool. It's got some good information in there, and it will give you more details than I'll be able to cover in today's presentation. So when we talk about PV inverters, basically they take the DC power and convert it to AC power, and they put that power back onto the grid. And when we talk about hybrid PV inverters, that will include the ability to actually have energy storage in the form of a battery or fuel cell and be able to do the charging control of the batteries and also use the battery power to put power back onto the grid. The device that we use for that is our 62000H family of products, which are solar array simulators. And the way we do that is we take various parameters to create the IV curve, which is embedded in the firmware and in the stored for use with and controlled by our internal digital signal processor. And that gives us the ability to create that actual variation in voltage based on the loading. And those parameters are built into a standard specification for the inverter. And you'll notice that when you look at the specs on an inverter, you'll find things like open circuit voltage, short circuit current, operating temperatures, and various power levels based on maximum radiation levels. And it also gives you things such as efficiency and also some various types of protection tests that are also good. So we created software for our units, and the software gives you the ability to control and create these different IV curves. And the curves themselves are created based on algorithms that were developed by Sandia National Labs and the European EN 5050 standards. And we also have internally the ability to do these settings and to create curves, but we also offer you the software to make it easier for you to save and store all the settings, as well as to collect data as you're running tests. Some of those, the soft panel or the general user interface, like we talked about, gives you the ability to set things such as irradiation levels, temperature coefficient, maximum power, and fill factor in order to generate and create the IV curves at different power levels. And we can do that very easily with the software, and also you have the ability to go in and change it very quickly by just selecting different power levels, and it will create that characteristic curve. Once you've done that, we load it into the memory internal to the actual 62000H power supplies, and from there the output will then react when loads change directly as you see it on that curve. So the voltage will change based on the different load. You'll also be able to track your PV inverters ability to find the maximum power point based on varying inputs, and that's the characteristic control of a PV inverter to do what's called maximum power tracking. And you'll see the red dot here that's displayed. That tells you where the power level is and the loading is based on your PV inverter being able to track that value. We can also do what's called simulation of shadows and variations in PV curves and IV curves. And you can see this on the bottom screen here. We have the ability to define an actual array by the number of different panels that would be in parallel and in series to create various voltages and power levels. We also have the ability to do create curves at different levels of shadow irradiation levels. So you can type in or input that data as well. You can also put in temperature coefficients based on different temperature. As you know, solar panels, solar arrays prefer cooler temperatures for maximum efficiency. So you can vary that temperature coefficient, see the effects it would have on your PV inverter by creating the different curves and variations on the output of our DC power supply. We also can do what's called dynamic maximum power point testing to understand how well your PV inverter will respond to input changes from variations of the power coming from the solar panel, we've created that ability here in our software. You can jump from different IV and PV curves and watch to see how quickly or how well your PV inverter's maximum power point tracking ability will be to maintain maximum power over time. We even have the ability to go and take real-world data. You can take live data. There's data available out there on the internet. Some of our national labs will make accessible data from their actual solar panels and solar arrays, and you can take that data and incorporate it into a test, and it will give you the variations also, as you can see on the bottom screen here for MPPT testing. We also can parallel, as we talked about, these units. We go all the way up to 1.5 megawatts of total power. So whatever the power level is, whether you're a small residential type PV inverter, all the way up to PV inverters used for larger installations and solar farm, we can help you with that and test that inverter for you. The next thing we're going to get to is how we simulate the grid. In order to fully test a PV inverter, you have to be able to tie it to a device that simulates the grid. It has to see the grid in order to synchronize to it before it can actually apply power back to the grid. So our Chroma 61800 regenerative grid simulators are perfect for that. Being regenerative, they operate both directions, meaning they operate as a source or a sink, and they can also put power back onto the grid. They're perfect for testing PV inverters, hybrid PV inverters under grid-tied conditions. So these particular 61800s have power capability all the way up to 105 kVA, paralleling all the way up to over a half a megawatt to 525 kVA. They can be operated, output can be selected single or three-phase from the front panel. And you can also use these all the way up to 0 to 335 volts AC line to neutral with our standard product. That gives you up to 579 volts line to line. We can also have the option to go to 400 volts line to neutral, gets you up to 609 volts AC line to line. These are perfect for testing industrial power in the range of 600 volt three-phase. Then we can even take that higher with our 105 kVA unit up to 0 to 500 volts line to neutral, 865 volt AC line to line. And if you really need to go even further, we have the ability to put two in series to get you all the way up to 1,000 volt AC line to neutral and 1,700 volts line to line. And these are more for solar power high-level distribution. It includes GPIB, Ethernet, USB, and RS-232. It has all of the different interfaces for controlling it, as well as it has analog inputs for when you want to use it, possibly for operations such as hardware and Bluetooth or hardware. The unit is regenerative as a when it's sinking power. It also has the ability to be regenerative when it's operating as an option that we have, which is a programmable AC load function. The unit operates in 4 quadrants. 4 quadrants simply means that we can act as a source, as the grid, to apply power to a load. And we can also sink current from the inverter, and we can also take that power from the inverter and put it back onto the grid as well. So being able to operate in all 4 quadrants is a necessity when you're testing PV inverters. You can see here with the simulation, and you can see our two scope screenshots. When the power is being driven to the load, basically the voltage and current are somewhat in phase. This would be, of course, a purely resistive load, but we can also drive reactive loads near power factor 0 as a source. So it gives you that full range. And as a sink, it will allow the PV inverter to put power back all the way to the grid. And we do it at 80% efficiency, meaning that 80% of the power from the PV inverter goes directly back to the grid, and only 20% of that would be dissipated internally in our 61800 AC source or a grid simulator when it's sinking current and power back. So only 20% dissipation means that compared to a fully dissipated load, your power levels and heat generated in your facility go down, and as well as you get the benefit of putting power back on the grid as well. Some of the test requirements for a PV inverter are defined by standards such as UL 1741 and IEEE 1547. There's a variety of different types of tests, and the guide that we offer to you that we'll supply to any of the people registered for this presentation, those will allow you to go into more detail, a better description of the test, and we'll give you more information. This is just a quick overview of what's referred to as anti-islanding testing. That's a test where the PV inverter is required to shut down within 2 seconds when a outage occurs on the grid. It also shows you another test below where we'll talk about low voltage ride through, and that is basically the ability for the PV inverter to continue to operate in small brownouts or small low time variation grid. So we have a lot more information on those. To cover all that now in this presentation would take an enormous amount of time, but if you have questions regarding UL 1741, IEEE 1547 tests, including the later version UL 1741 SA and the IEEE 1547 2018, that covers additional tests for the PV inverters. We'd be happy to go in more detail and give you support on that. Some of those standards that we just talked about, we talked about would be testing the PV inverter for trip and no trip condition under anti-islanding, low voltage, high voltage ride through, and low frequency and high frequency ride through. There's also something referred to as ramp rate, which talks about how the PV inverter would actually ramp up and to start putting power back onto the grid. Specific tests for that are well defined in these standards, and we have the ability to help you with that. These particular charts just kind of give you an overview of what those tests look like, where the normal conditions are, the high frequency, low frequency. The bottom figure 6, figure 5 shows you high voltage, low voltage reading, as well as normal operating parameters. Another thing that we can produce on this unit is power line disturbance. The programmability of our 6100 grid simulators are really incredible. They've given us the ability to do sags, surges, or swells, small interruptions at very small incremental times down to a portion of a cycle, and also be able to inject or generate noise, notches, those types of things that are mandatory tests based on IEC 61000. We have a soft panel or a general user interface that gives you full access to all of these different controls that make up those types of tests. And our soft panel is an option. It's a LabVIEW standalone executable file. You don't need LabVIEW to use it. It's a fully standalone software package. And it gives you all the capabilities to do things such as programmable sequences, up to 100 sequences. You can get timings down to less than a millisecond and also up into minutes. It can give you the ability to do testing for IEC 61000 tests that include things like short interrupts and harmonic distortion, interharmonic distortion, and variations of voltage frequency. We have the ability to save and store this information also internally in 61800, save up to 10 of settings. And of course, externally, when you're using the software, you can save as many setups as you want and recall those by opening them through any files that you store on the computer. The transients that we talked about briefly, this is one example that's kind of an exotic example. It shows a clean sine wave operation. Then it shows switching over to a distorted waveform, harmonic distortion, followed by a short interrupt back to a low voltage and then back to a high voltage. And we can do these in very short incremental changes. So this gives you kind of an idea what that looks like. The scope screenshot below shows you the actual result, the output. I did it on a single phase to make it easy to show you what that looks like. But on the 61800, you can do this on each individual phase or all three phases. The other thing that we can do is called pulsing. Pulsing allows you to inject short interrupt of the cycle. It can be at different levels. It doesn't have to be to zero, like I'm showing in this one. And it gives you different counts, how many times you want to repeat it. The trigger button will actually inject that into a output when it's up and running. So, and you also have the ability to use a signal on the back of the unit to trigger your scope or to allow you to trigger it at the right timing to capture that. As you can see what I did here with the scope screenshot on the right side. We also have the ability to do waveform synthesizer to add various types of harmonic distortions. You can do it all the way up to the 50th harmonic, different percentages. You can even add a phase shift between the fundamental frequency and the harmonic distortion. And you can do that at 50 and 60 hertz fundamental frequency. You can do it in value or you can do it in percentage. And again, this is something that you can have the output up and running. You can hit the trigger button that will trigger and run a particular sine distorted waveform and at different intervals, different voltages, and different phases. The other thing about this unit is we can also measure the harmonic distortion internally with the measurement capability. You can see it manually. There is a measurement that you can go to on the front of the unit. It will give you the access to harmonic measurements. It gives you all the 50th up to the 50th harmonic. It will graphically display it for you for both voltage and current harmonic. And it'll also display the actual raw data for you as well. And this can be downloaded to a report. You can save the data and analyze it externally in Excel or other types of files. The other thing, key part of this unit is when you're testing a system is the measurement capability. Now, our solar array simulator has the capability to measure its output voltage, current, power. The Chroma 61800, as we just showed you, has great capability to do measurement. But we also give you the ability to do additional measurements using our digital power meters. The 66204 digital power meter is a multi-channel meter. It gives you up to 4 channels. As an example here, you'd be able to measure the DC input power to a hybrid PV inverter, as well as measure three-phase output of the PV inverter for AC. It'll also give you the ability to measure the battery charge and battery power supplied back from the energy storage system as well by using the power meter. You can measure voltage, voltage peak, current peak, surge currents. There's an enormous amount of things that you can measure with this unit, including energy and efficiency. So with the hybrid PV inverter, like you see here, or any PV inverter, measuring the input power and the output power gives you the ability to also display the efficiency using a 66204 power meter. The 66204 power meter family of products includes a three-channel, four-channel, and we also have a single-channel 66205. The accuracy is incredible on these units. They have built into them internal shunts, 20 amps. On the multi-channels, each one has its own independent shunt and measurement capability, so you can do simultaneous measurements of all three phases or all four channels. And also gives you the ability to use current transformers and shunts externally to increase the current level measurements and also increase the power on this one. We also offer a nice soft panel or general user interface that gives you the ability to graphically display voltage and current, see here in this screenshot, as well as gives you the numeric measurements of a variety of different measurements, that all the measurements that the unit can handle, as well as you can display up to 6 at a time. In the report generator, you'll be able to capture all the measurements simultaneously, and as well as be able to, with our software, capture some of the graphical data as well. So when you're testing something like a PV inverter, this just tells you a little more about how we use that four-channel digital power meter. The 66204, you'd use one channel for the input, three channels for the three-phase output, and you'd be able to capture all the data required to collect data for efficiency, energy, and to be able to even see the capability of your PV inverter as far as how clean power output it can do, and make sure that it meets the 0.5% distortion that standards require before it can put power back into the grid. The soft panel, or the general user interface, they've done a great job on this. I have to reach out to our R&D group. They've done a wonderful job producing a great tool to enhance the capability of the power meters. Here you can see on the left side, you can graphically display voltage and current. You can see the distortion in the current. You can see the sine wave blue of the voltage. And you can actually set parameters, harmonic distortion, voltage levels, various types of limits to actually do testing with particular software. On the right-hand side, you can see the ability to measure harmonics all the way up to the 50th. We can actually measure up to the 100th harmonic with this particular, our 6605 product, and it will graphically display them. It'll actually show in yellow the actual limits based on IEC 61000 standards, and it will give you pass and fail data based on that. It'll also give you the numerical data. It'll put it into a great report, and you can also use that data for analysis. To do a hybrid inverter charger, to do a hybrid PV inverter charge controller energy storage testing, it does require that you have the ability to simulate the stored energy device, such as a battery. So our 17020, 17040 battery tester, battery simulator is the perfect tool for that. We have two variations, the 17020, which is a multi-channel, a lower power device, and for high power, we go into the 17040 as well. And so I'm going to cover some more detail on these devices, and we'll go into that with you on the next slide. The 17020 regenerative test system can do battery simulation. It can do charge and discharge testing of batteries, as well as simulate a battery as a load when it's being charged, or as a source when it's being used as supply power. It comes in different models and it has up to 7 different models ranging from voltages, 60, 20 volts actually, all the way up to as high as 500 volts. This particular unit has a variation in different current ranges as well, and multiple channels. The 17040 is the big brother to this unit. It's a single channel unit for higher power. It can get you all the way up to 300 kilowatts, voltage range up to 1,000 volts. And they're fully programmable. They have variations in the operation of constant current, constant voltage, constant power when working in charging, battery simulation. It also gives you other applications for simulation, real-time driving and simulation for electric vehicles. We have more slides on this. This was actually presented about 2 weeks ago on one of our webinars by another engineer by the name of Gus. And if you'd like more detail on this type of information, we'd be more than happy to send you a copy of that presentation, or we'll be happy to get online and discuss it more. The previous ones also, the 61800 was something that I presented a couple of weeks ago, or a week ago. And also, if you want more detail, we can send you that presentation. In order to give you more detail, if you want to have a one-on-one discussion about it, please contact us, reach out to us, and we'll be happy to set that up. So when we talk about the battery simulation for this particular product, it gets into various charging and discharging simulations, as well as the ability to simulate the state of charge for the device, even things such as DC resistance of the battery. We can do all of these various things, and programmable. There's a nice software package for it. And again, there's a lot of information on this that was presented by Gus on the previous webinar. And for more detail, please reach out to us and we'll be able to get you that information. And of course, I would not be doing my job if I didn't mention the ability to do a complete automated test system for you. And our automated test systems group here in our facility, they do an incredible job. We have proprietary software called Power Pro, and we also have Battery Pro software. And they do entire automated test system custom to your requirements. And they've done a great job in putting together systems also for testing PV inverters. So please reach out to us if you have a requirement to do a completely automated test system. Our system integration system engineering group would love to work with you on any of your projects. I'm going to open it up for questions, but for some reason, I'm missing my that page on this screenshot. I'm going to reach out to maybe for one more support. Steve, maybe you can walk over and give me a hand on this, but please use the chat room for any of those and questions that you might have. We'll be happy to answer your questions. I apologize. We just ran into some more difficulty with this particular setup, and I apologize for that. If you're still hearing me, please go ahead and reach out to our chat room, and we'll be able to work with you